Okay, there we go with the okay again. Understanding multiple zeros, so higher multiplicities than just one. So we've got a couple graphs here. Just to reiterate again, higher multiplicities. So this first graph, f of x, its 0 is at -3 and +3. But at -3, it's got a multiplicity of 3, right? It's x plus 3, so here's the function down here. So it's x plus 3 cubed, which means it has odd multiplicity bigger than 1, and so that's why it's got this sort of S shape in it, right? It's got an S shape there at 3. At the +3, it's x minus 3 squared, so that 0 has even multiplicity, and so it bounces, right? Even multiplicity bounces. And so the same thing over here in the second graph, just to reiterate again, it's the odd multiplicities cross. If it's a multiplicity of 1, it crosses nice and smooth. So this first one is a 1 multiplicity. Alright, because it's crossing it without, there's no kink or S shape. Over here, it's got a higher because it's got that S shape in it, right? So it's a higher multiplicity. In this case, the higher multiplicity is 3. Alright, so again, that's sort of the behavior of the graph. So keeping that in mind when we solve the following examples. Alright, so we want to find the x and y intercepts. Determine the multiplicity of the zeros, which are the x-intercept, and how they affect the graph. Then sketch the graph by hand, using what you know about the zeros and the end behavior. So pay attention to the end behavior that we learned about in the earlier sections of Chapter 4. Alright, so the first one I'm going to find find my intercepts. Alright, so the y-intercept's the easiest. That's when x equals 0. What's my y value? So I plug 0 into my function. And so I get 0 squared, 0 plus 3. Well, that zeroes out. So 0, 0 is my y-intercept. Alright, my x-intercepts is when my y equals 0. What's my x value? Or my function equals 0. So set my function equal to 0 and solve. Well, I actually have 3 factors, right? I have x squared, which is x times x, and I've got x plus 3. And so x squared gives me out a 0, x plus 3 gives me out a 0. And so I've got a 0 at 0, and I've got a 0 at -3. Alright, so my x-intercept, we're at 0, 0, which actually is also my y-intercept, so this is, and at -3, 0. Alright, and so those are my zeros. 0, there's actually 2 of those, right? Because the x squared really means x times x times x plus 3. So my 0 has a multiplicity of 2. Alright, multiplicity of 2. Alright, I might write it over here. This has a multiplicity of 2. The -3, it only showed up once. There's only one of those. And so that has a multiplicity of 1. Alright, so there's part B. Except for how does it affect the graph? So at 0, 0, since it's a multiplicity of 2, it's going to bounce off the x-axis. And at the 0, -3, 0, it's going to cut nicely, smoothly, across the x-axis. There's going to be no S shape. It's a smooth crossing of the x-axis. Alright, so keeping that in mind, so there's B. Alright, then the last one was, alright, so find my x-intercept, find my y-intercept, determine the multiplicity and how it affects the graph, sketch the graph by using the zeros and the end behavior. And so, first my end behavior. So this is what we talked about in the earlier sections of Chapter 4. And so, first of all, what is the degree? Alright, so if I multiplied this out, it would have a third degree, right? I've got x squared times this x, and so my degree is 3. and a is 1, which means a is positive. So that means as x is going to infinity, so are the y values. As x is shooting off to negative infinity, so are the y values shooting off to negative infinity, right? When I plug negative values in, because it's cubed, they stay negative, right? And the a is positive, so they do that. So keeping that in mind is my end behavior, and then using that to graph it. So I'm going to sketch my graph over here. Then you can always plug them in your calculator and double check your answers as well. So 1, 0 is at 0, 0, and then negative 3, 0. I know that I'm going to be shooting this direction and this direction, right? Up from negative infinity up, and then shooting up to infinity on the... So from the left side, I'm going down to negative infinity. The right side, I'm going to positive infinity, right? That's what this behavior tells me. It tells me I'm shooting up like that and down like that. I know that at negative 3, 0, it's going to cut nicely across. So when I come up, it's going to cut nicely across. And then I know at 0, 0, it's going to bounce. So it means it's going to come up somewhere, and this is where I just have to guess how high it goes. Somewhere up here, it's going to go up, come back down, and then at that 0, it's not going to cut across. It's going to bounce, and then finish off my end behavior. And so this is the sketch, meaning that's the shape the graph should have. It should cross nicely at negative 3, 0. It should bounce at 0, 0, should be shooting off to infinity at this end, and negative infinity at that end. And so there's my C. Alright, my next example, which I might give myself more room. So I didn't give myself a whole lot of room there. Alright, so I'm looking at example 2. So first, find my intercept. So my y-intercept is when I plug 0 in. Alright, x equals 0. What is my y value? It's a really big y value. I've got negative 2 cubed, which is 8. Negative 8 times negative 1, and then 4 squared, so 16 times 8. So 128. Alright, so that means if I were to graph this, it's going to be way up on my y-axis. My window's got to be fairly large. Alright, so there's my y-intercept. Alright, my x-intercepts. This is the zeros of the function, where my function equals 0. My g function equals 0. So set them equal to 0. This is why it's nice to have them in factored form. There's only 2 factors. 2 different factors. There's actually 5 factors, but there are only 2 different factors. There just happens to be 3 of the x minus 2's and 2 of the x plus 4's, which means the multiplicity matters. Right, this first factor is going to give me a 0 at 2, and the second factor is going to give me a 0 at negative 4. Right, so there are my zeros. So those are my intercepts at 2, 0, and negative 4, 0. Now they're multiplicities. There's part A. Alright, part B. The 2, 0, and the negative 4, 0. Well, they have multiplicity. There are really 3 of these, x minus 2, so my 0, 2 has a multiplicity of 3. It's got odd multiplicity, bigger than 1. Negative 4 shows up twice, so it has even multiplicity of 2, which means at 2, 0, it's going to cut, but have that S shape when it does. It's not going to be a nice smooth cut. It's going to flatten out and have that S shape. At negative 4, 0, it's going to bounce. All right, it's going to bounce off my graph at that value. All right, so again, those are the two zeros but different multiplicities. All right, the last part is the end behavior and then the graph. Well, since this is x cubed and y squared, my degree would be cubed and squared, which would be 5. And then I've got that negative out front, so a is a negative. So a is negative 1 less than 0. Its degree is 5, so I've got an odd degree, so it's going to be opposite of the last one. Alright, as x shoots off to infinity, my y values are going to go to negative infinity. As x shoots off to negative infinity, y is going to shoot off to positive infinity, right? The shape is, alright, I've got stuff going on in the middle, but it should be going up on the left, down on the right. Alright, that's the end behavior, and that's what it's going to do when I go to sketch my graph. Alright, so I'm going to keep that in mind when I sketch my graph. So first of all, I'm going to mark off my zeros. My zeros were at 2, 0 and negative 4, 0. So remember, I'm coming down to the negative 4 and it's going to bounce, right? Negative 4, it bounces. So I'm going to come down. I'm not going to cut across. It's going to bounce and come back up. Now actually, it's going to go way up because remember, my y-intercept's way up here at 128. So we'll probably be off my page. So I'm going to go fairly high and come down. So I'll go way up because again, way up there at 128, it's going to hit, come down. And then keep in mind that at the 2, it's got a multiplicity of 3, so it's got to have that S shape, right? I've got to have that S shape when I go to graph it. And so it's not going to cut nicely across. It's going to come, actually I might have arced it too much, flatten out at that moment. So I'm going to kind of redraw this. My Y's in my way. Come down, flatten out. Again, remember it has that S shape there. And so it's got a little kink in it. Alright, and so that would be at the multiplicity of 3. So there should be, it's not a smooth crossing. Like I said, there should be an S-like shape there at 2. And when you graph it, it should look like that on your graphing calculator. Now, keep in mind this will be way off your window because this goes all the way up to 128 when it goes all the way up. So it'll be off your window, but that's the general shape of it. Right, that's the shape of it. Which, what I can tell from this is when the function's positive or negative, right? I know it's negative after 2. I know it's positive between the 4 and the 2, and from negative infinity to negative 4. It's kind of where we use these things. At the last one. This one's kind of nice. It's a nicer one than the last one. All of them have multiplicity of 1, right? So we'll cross that bridge when we come to it. So first of all, though, my y-intercept. So again, when x equals 0, what's the y value? Well, I'll plug 0 into that function. And so it's going to be 0 minus 2, 0 plus 3, 0 plus... So it's going to be negative 2, 3 times 7. And so my y comes out negative 42. So again, keep that in mind. It's going to go way down to negative 42 if you're checking it on your graphing calculator. Alright, so there's my y-intercept. Now my x-intercepts. Again, it's when my function equals 0. So each one of those give me a 0, so I've got a 0 at positive 2, a 0 at negative 3, a 0 at negative 7. So my zeros are at 2, 0, negative 3, 0, 0, negative 7. They all have multiplicity of 1. That means they all cross nicely. They all cross the x-axis nicely. Cross the x-axis smoothly. It means there's no kink in it. Nicely, smoothly drawn. So there's B. Alright, C then, end behavior. Apparently I picked all odd end behavior, no even end behavior. This is a cube, right? This would give me an x times x times x, which is a cube. Number out front is 1, so A is 1. It's greater than 0. It's got a degree of 3, which means it's going to have end behavior as x goes to infinity, so do the y values. As x goes to negative infinity, so do the y values. So again, middle stuff's going on, but it's going to shoot up on the right, shoot down on the left. When I go to graph it, I'm going to mark off my points and sketch it. Alright, so there's my y-axis, there's my x-axis. I have a 0 at 1, 2, 3, 4, 5, 6, negative 7, negative 3, and positive 2. And then it goes way down here at negative 42, which again would probably be off my page, but I'm going to mark it way down there. Keeping in mind, this is the end behavior, so I start down, and every time it's just going to cross smoothly. So I'm going to go up, and this is where I'm just guessing how high it goes. So it's going to cross smoothly, cross smoothly, come down, hit that 42, cross smoothly. And so again, that would be the general shape of my function. Right? And it should match that a little bit. Now how high up it goes, this is just guesswork how down low it goes. I know it goes fairly low though because it hits the intercept at negative 42. And that would be the general shape, which from the shape I can tell when it's increasing, when it's decreasing, when it's positive, and when it's negative, right? I know when my function's positive, well, between the negative 7 and the negative 3, and from 2 to infinity. I know when it's negative, from negative infinity to negative 7, and between the 3 and the 2, right? So when we go to solve inequalities, which we are going to eventually do, that's kind of helpful information. All right, we'll stop there. The next video, we'll pick up the next set of notes, which is factoring. So finding these zeros, factoring completely, using a different method than graphical and synthetic, although we do kind of use this hand in hand with synthetic. All right, so we're going to do more factoring in the next set of notes.